Okay, so looking at something like this, we have two polygons. You are going to start out on the test seeing similar polygons. So if I tell you these are similar, even if I didn't tell you they were similar, you could look at the angles. So each polygon has a green angle, each polygon has a red angle, each polygon has a blue angle, and then two blank angles. So these are similar polygons. Now we know with similar polygons, similar triangles, you set up ratios of corresponding sides. So if I told you to solve for x and y, you would go through and you would set up two different problems for them. So let's set up a ratio for x. So I'm going to just start with what I'm looking for. So it's x plus 2. So x plus 2 over, you've got to find the corresponding side on this other polygon. What's the corresponding side? 10. Now you knew that because it's between green angle and red angle. So you're right. It would have to be over 10. Good. Is equal to, now I'm going to pick one other side that I know on this polygon and one that I know on this one. So I'm going to just go with, why not 3 and 14. Now a couple things, make sure you stay consistent. So notice this polygon over here on the left is what's on top on both, which should be true, and on bottom on both is this polygon. So I stay consistent. I went from here to here, and then from here back to here. So then from here, you'd have to cross multiply and solve. So we multiply both sides by 14, but it will divide out on this side. Multiply both sides by 10, but it will divide out on this side. Don't get this far on the test and then miss it. You're gonna have things like this, so you have to put those in parentheses. So then you distribute it through 14 times x, 14x, and then 14 times 2 plus 28, very good, is equal to 30, right? And then I would subtract 28 from both sides. So I have 14x is equal to, 14x, that was a weird x, is equal to divide both sides by 14. And you're going to see answers on the test that are fractions. So x is equal to, now you do that in your calculator, you would do 2 divided by 14. And on the test, I noticed, especially on problems like this, we don't have any decimals. So you have to change back to a fraction. So make sure you can do that. 2 divided by 14, you hit enter on your calculator, it's a decimal. And if it was a multiple choice, you have to know how to switch back to a fraction. So you hit the math key, then hit enter, enter, and it's 1/7. So x is equal to 1/7. Okay, so we've solved for x, now solve for y. We'll set up a ratio of corresponding sides. So I see that we have y minus 2. So we'll set up y minus 2 over what's the corresponding side on the other one? You know it's 16, very good, because it's between green and blank, right? Okay, so y minus 2 over 16 is equal to, use a side over here and a side over there. Let's just use 3 and 14 again, why not, right? 3 and 14. So it's equal to 3 over 14. Then we would cross multiply both sides by 14. That has to go in parentheses. It'll divide out over here. Multiply both sides by 16, but it will divide out on bottom. So then we have 14 times y, 14y. 14 times negative 2 is negative 28, which is equal to 3 times 16. Yep, 48 good. So it's equal to 48. Then you would solve for y, you'd add 28 to both sides. Make sure you're doing inverses correctly. So we have 14y is equal to, yep, 76. Then divide both sides by 14. So you got a decimal, right? Okay, now like I said on the test, it's multiple choice. One like this, and you'd have to change back to a fraction. So math, enter, enter, and it's 38 over 7, right? That's the most simplified fraction, 38 over 7. Is everybody okay with that? You will see a polygon. Might not look exactly like this, but what do we do with all polygons and triangles? We set up ratios of corresponding sides, cross, multiply, and solve, right? Are we all okay with that one? Okay, moving on. All right. Okay, so the next one I want to touch on is one like this. So everybody look with me at this one, because we have two similar polygons. We have this one and this one. I'm telling you, on the test it will say, okay, these polygons are similar. Now looking at this, can we tell which side corresponds to which side? I mean, we can go off the picture pretty good on this one, right? 8 corresponds to what? 20. And then 4 corresponds to x. So we would have said 8 over 20 is equal to 4 over x, like this, right? Now if we were going to solve for x, we would cross multiply both sides by x, right? But it divides out down here. Multiply both sides by 20, but it divides out down here. Now, let's say I didn't finish solving for x. Let's say that I said, tell me a correct ratio on this one. Well, what if they didn't have this ratio? 8 over 20 is equal to 4 over x. What if they had some other? What if it was multiple choice? Couldn't we check all the ratios and see which one's equal when we cross multiply? So, like, look over here. What if I had 8 over 4 is equal to 20 over x? Could we cross multiply and see if we got the same thing? That's what we would do. So let's multiply both sides by x, right? Because x is on bottom. Multiply both sides by 4, but it divides out over here. So look, we have an x times an 8, and then is equal to 20 times a 4. Is that what we had over here? X times 8 is equal to 4 times 20. Same thing as 20 times 4, right? So are you guys going to be able to use your knowledge to like do a little bit different of a problem? Now that you've seen that, you should be able to, right? So what I'm saying is their ratio might be set up differently, but just say, I know for a fact we can set up ratios like this. We've been practicing that. We know this is right. So then check all the other ratios and see which one is exactly equal on both sides. Does that make sense? Yes? Okay. Or you could go through and solve for x in each of them, because you're almost there, right? And then which x is equal to this one. Does that make sense? You could do that? Okay. You could solve for x in each problem and see which one was equal to your x that you know for sure works. Does that make sense, or am I confusing you? We're all good. Okay, can I move on from this problem? You're sure no questions? Like, you guys are here to get extra help. You're sure? Okay. Okay, so are these polygons similar? How would we do this one? These are weird shaped polygons, but what do we know about polygons? The ratio, because we're not dealing with angles in this one, are we? So we would set up ratios of corresponding sides and check them all, right? We have to check every single one of them. On the test, you will see something like this. So 8 is to, so 8 over 4, and I've got to stay consistent. Now notice I happen to just start over here on the right, so I've got to continue to start on the right. So 8 over 4 is better be equal to, let's go up here, 4 over what? 2, 4 over 2, and that better be equal to 9 over 3, and that better be equal to 6 over 3, right? Okay. And you would actually take your calculator, divide it. 8 divided by 4 is 2. 4 divided by 2 is 2, but you could just use your calculator. 9 divided by 3 is 3. 6 divided by 3 is 2. So are these similar? No, we had one that was off. Okay, they're not similar. So you would say not similar because the ratios didn't match up. Now this one might be multiple choice on the test too, and you'll have to choose the correct no or the correct yes. So if it was, let's say it was, you'd say yes, and then the answer would be no because all the sides were the ratios matched up. But if it said no, you'd have to choose the correct no. So what if I said, what if the option was no because 8 fourths does not equal 4 halves? Is that a true no? No, those do equal each other, right? So you choose a different no, the correct no. Does that make sense? Okay. So another no would be 4 halves does not equal 9/3, and that's true. Does that make sense? Everybody good? Are you sure? Okay. Okay, so now you will be given something like this. 2 triangles, and it will say, given the triangle ABC is similar to triangle DEC. Well, using your similarity statement, you can tell which angle goes with which angle, right? B goes with E, C goes with C, right? Oh, and I didn't even label them A, B, C, but A, B, C, and then D, C. Okay. So looking at these 2 triangles, if we were given that they're similar, and we were asked to solve for x and y, we would set up a ratio of corresponding sides, right? So we would go x over what? X over 7 is equal to, can we do 10 over y? No, because then we have two variables. So we need to go 3 over 3. Good. Does that make sense? Then we would cross multiply and solve. So we'd multiply both sides by 3, but it will divide out over here. Multiply both sides by 7, but it will divide out over here. So 3x is equal to 21. Divide both sides by 3. And x is equal to, does that make sense? Okay. And 21/3 is a decimal, right? But like I said on the test, well, on this one, yeah, this one might just be fill in the blank probably. So you could do the decimal or the fraction. I'll take either answer, but it has to be the simplified fraction. So what'd you get? Yeah, that's true. Yeah, because that would be 1, and then, yeah, true. Okay, so let's do another ratio for y. So since I'm solving for y, I'm going to put that first. I got to stay consistent, though. So now I'm starting over here. Y over, what goes with y? 10 corresponds. They both sit in the same spot. Y over 10, now I got to stay consistent. I was on this triangle, is equal to 3 over 3. Let's use that again. Why not? 3 over 3. So then we cross multiply both sides by 3, divides that over here. Multiply both sides by 10, divides that over here. 3y is equal to 30, divide both sides by 3, so y is equal to 10. Okay, you will see one like that on the test. Are we all okay with that? Okay, that one wasn't too bad. Okay, you will see one that simply just says, find the geometric mean, period, end of story. Find the geometric mean, no picture, just exactly worded like that. We would set it up like this. Blank over x is equal to x over blank, right? And then we would fill in our numbers. So it doesn't matter. We can put 122 up here or down here, 7 up here or down here. So I'm just going 122 over 7. Then we would cross multiply. So multiply both sides by 7, but it divides out over here. Multiply both sides by x, but it divides out over here. So 854 is equal to x squared. And then how do we get rid of the square? Square root both sides of the equation. And then our root cancels out our power, and you'll type in your calculator the square root of 854, 29.22. Questions on geometric mean? Are you all okay with setting one up like that? Yeah.
Do we have to have it to the 10th decimal?
I will specify what decimal. Yeah.
How do you do the square root?
You hit the second key at the top, second, and then go down a few keys straight down, and where it says x squared, you click that, and that's the square root. Yeah, good question. You'll know you have a problem if you put 2, if you haven't, like, what I'm saying is it has to be, 1x has to be on bottom, 1x has to be on top. You understand that, right? Right, everybody? Okay. No questions on geometric mean. All right. Okay, let's do this one. You will have a right triangle one. Let's go through this one. Okay. This is the hardest one probably for most of you. Okay, so looking at this, guys, a couple things to look at because there's going to be other problems that look like a right triangle that aren't a right triangle. And you won't want to use right triangle if it's not, right? So we know that this is a huge right triangle because of that right there. Okay? And then we're dropping an altitude down from the right angle of the right triangle, and it makes another right angle right there. Well, if that's a right angle, then wouldn't this have to be a right angle as well? Yes. So we have these 3 right triangles. I'm telling you to go off to the side on the test. Draw it consistently. Go like this. Okay. I'm going to draw my short side on bottom, my tall side on top. There's my small triangle. I draw it in the right angle. Then I'm going to draw in my medium triangle. Staying consistent. Do you see how my pictures look consistent? I'm making this the shorter side, this the longer side, and then the hypotenuse is all facing the same way. Then I have my large right triangle. And now we'll go in and fill in our information. So be so careful with this. It shouldn't be too bad. We've had harder right triangles than on the test. So you should be able to do it as long as you fill in your triangles correctly. So I'm going to start on my small triangle, okay? Across from the 90 degrees is our hypotenuse. So where does X go? Across from the hypotenuse, across from the 90 degrees at the hypotenuse, so X is right there. Does everybody see that? Okay, I gotta fill it in correctly. Now remember, when you drop down this altitude, you have to think about this. When you drop down this altitude, on the small triangle, it's our long leg, right? So this would be our short leg, right? So 4 is our short leg on our small triangle. So this is 4. Does everybody understand that? Okay, now let's fill in the medium triangle. So now I'm filling in the medium triangle here. Across from the 90 degrees is Y. So I'm going to go to my 90 degrees, go straight across from there. Y is right there. And then once again, you have to think about the altitude. On this, the altitude on the medium triangle is our short leg. On the medium triangle, it's our short leg. So then what's our long leg? 8. So 8 goes right here. Questions? Now you have to fill in your huge triangle correctly. So look at this huge triangle. Ignore that line in the middle because that's just cutting through the middle. That doesn't affect us now on this huge triangle. What's my hypotenuse across from the 90 degrees? It's that whole side, right? It's this whole side. 8 plus 4 is 12. So 12 goes, now draw it correctly. Don't, and a lot of you put 12 over here. That's not true. It's across from the 90 degrees. So 12 needs to go right there. And then from here, looking at our picture, isn't Y definitely the longer leg?
Yeah.
So Y is going to go up here, and then what goes on bottom? X. Okay. Are you all okay? Now we'll set up ratios of corresponding sides. So I'm going to start with X. Why not? So I'm going to do X over, you can't do on the same triangle, keep that in mind. So X over, are we going to use the medium one? No, because you have X over Y, which isn't going to help us. So X over what? 12 is equal to, now I'm going to go back to here, and the only side we have is 4, so we must be using 4. 4 over what goes with 4? X. Did everybody see how I did that? Okay, well good. It's good you realize it now, right? So then you cross multiply from here. And multiply both sides by X because it was on bottom, but now it divides out over here. Multiply both sides by 12, but it divides out over here. So we have X squared is equal to 48. Then you take the square root. So X is equal to, and this will be multiple choice on the test. So you got to be so careful, but you're right. I'll take decimals on it. So 6.9. Okay. All right, let's solve for Y. Now look on our medium triangle. Y is the hypotenuse, right?
Yes.
So I got to set up ratios of corresponding sides. And I'm not going to use X because I would have to use the full long decimal. That would be miserable, right?
Yeah.
So I'm going to use something we already have. So Y over 12, those are corresponding. So Y over 12 will be equal to, we've got to come back to this triangle. The only side we have is 8, so we must be using 8. 8 over what goes with 8? Y. Was that too bad? No, that's as hard as it's going to be on the test. So then we cross multiply both sides by Y, but it divides out over here. Multiply both sides by 12, divides out over here. Y squared is equal to, is that 96?
Yeah, I think it is.
Okay, and then square root both sides, and the decimal is 9.8. Okay, now on the test, it will be multiple choice. You got to be really careful because they're going to have answers that are switched around. So they'll have things like your X value will be your Y value, your Y, do you know what I mean? So you got to be careful when you go to the multiple choice to make sure you choose the section that says X is equal to 6.9 and Y is equal to 9.8. Because if you just look at your answers and see 9.8 and 6.9, it might be the wrong variables. Does that make sense? So you got to find the right one. So then we would know this would be your answer, right? Is everybody okay with that? Okay. Sweet. Okay, looking at this one, this is one that's probably even trickier than the last problem because it tricks so many students. You'll see one like this. First of all, is the huge triangle a right triangle?
No.
No. So we're not going to split this up using right triangles. Very good. This is not a right triangle. It would say it was a right angle right there if it was. So we don't have to use the method of right triangles. In fact, we wouldn't on this one. Okay, but look at this. This one's kind of tricky. Looking at this, don't we have two similar triangles here and here? Well, let's think about it. If this is 90 degrees, what's this? 90 degrees. So now looking at this triangle, we have a 90 degrees and we have a blue 2 dashes, right?
Yes.
And then on this triangle, we have a 90 degrees, right? And 2 blue dashes. So are they similar? Yes. Okay. Now this will help you on the test. If you say, okay, I see that they have this angle and this angle in common, this angle and this angle in common. So the third angle must also be in common, right? Everybody, if 2 angles are the same, then the third angle would be the same, right? So it will help you if you draw in, like, instead of doing a single dash, do double dashes or vice versa. So that you know, okay, well then those angles must be the same. Do you see what I did there?
Yeah.
Okay. But obviously don't, if they write it as a single dash, don't do single dashes again, because then you'll get them confused, right? You got to specify something different. Does that make sense? So now we can see which side corresponds to which side much easier. So we know if we're solving for x and y, we have to set up ratios of corresponding sides. So I'm going to solve for x first. Now x is on this triangle right here, right? Okay, so x over, well, x is the across from the 90 degrees, right? So on the other triangle, what's across from the 90 degrees? 4. So x must be over 4. And that will be equal to, now I'm going to come back to this triangle, and I'm going to find another side. Should I use y? No, because then we'll have an x and a y, right? We won't want to use y. But couldn't we use 2? Okay, so we're going to use 2. It is on this triangle too, right? It's on both. So this side is 2, so I'm going to use 2. Now this is the trickiest part. How can we decide, since this is 2 on this triangle, which side corresponds over here to that? Well, 2. Not true.
X.
Not true. Nope, not true. So everybody look with me. On this triangle, we decided to use 2. 2 is between 90 degrees and blue, right?
X.
So look up here. What's between on this triangle 90 and blue? 3. That was kind of tricky, wasn't it?
Oh.
Okay, so you gotta use your angles to know corresponding sides. Does that make sense? Do I need to say it again? Are y'all sure? So on this triangle, once again, so on this triangle we use x. You get the x over 4.
Yeah.
Okay, and then this 2 is right here as well, right? 2. Okay. So then we have to use on this triangle a side. So we're going to use 2. 2 is the side between 90 and 2.
Oh.
So then you have to look at your other triangle, find 90 and 2, and then what's between 3. So that was really tricky. So then we cross multiply 3x is equal to 8. Multiply both sides by 3, divide that over here. Multiply both sides by 4, divide that over here. Divide both sides by 3. So x is equal to 8/3, right?
You want it like that or this way?
It depends on the problem, but really, if it's multiple choice, I would do both. I mean, if it's not multiple choice, I'd do both. And if it is multiple choice, whichever they give you. Okay, so let's set up another ratio to solve for y. So everybody watch, because this is it is tricky. So y is on this triangle, right? So I'm going to do y over, we've got to think carefully, what's the corresponding side? So look right here. Y is between green and red, right?
Yes.
So looking over here, what's between green and red? 2. So y over 2 is equal to, Now we started on this triangle, we gotta stay consistent. Let's not use x because we don't want to use the full decimal, do we? So let's use 2 again.
Okay.
Yeah? So 2 over, and what was with 2 on this triangle? 3. And we knew that once again because 2 on this one was between double and red. Double and red on this one would be 3. So then we would cross multiply. We'd have 3y is equal to 4. Divide both sides by 3. So y is equal to 4/3.
So can you choose like any angle to correspond to as long as you stay consistent?
As long as you stay consistent. It's just the only thing is really if we would have chose the only other one we knew, we had to use 2, right? Because we would have had x and y's on the first one, if not. And then the second time, the only reason we chose to go with 2 again is because we didn't want to use the full decimal. So, but yeah. Are you all okay with that? Okay. If you needed to split these up, you could redraw them. Just remember, like, you're like, oh, up here, this triangle had 2 and then 1 and 90 degrees, and you got to fill it in correctly. So your 3 would have been right there, right? Your 4 would have been right there, and your 2 would have been down there, right? Then you could have split this one up and drawn it the same way and said we have another one. Now we're drawing in this one. Our 2, we have a 90 and then a double and a single, right? Are you still following me or am I just?
I'm following.
Okay. So then on here and across from 90 degrees is x, right? Across from the single was 2, so single across is 2, and across from the double was across from the double is y. So then from there you could have set up ratios, right? Okay. No questions, you will see one like that. Okay. All right, looking at this one, let's solve for x and y. You'll see one like this. So notice, looking at this, we have a triangle, and we have these 2 parallel lines. We know they're parallel because of those things. So we have a couple different ratios we can set up. We can do 15 over 7 is equal to 16 over y. So I'm going to set that one up. 15 over 7 is equal to 16 over y. Does everybody remember why we can do that? Yeah? Because they're this, yeah, the ratios will be cutting the sides proportionately. But now for x, this is where most students miss it on the test. For this bottom part down here, not necessarily going to be x on the test. It might be a or b, the variable a or b, or it might be y. But you to find this bottom part here, can we go 15 over 7 is equal to 12 over x? No, that would be incorrect. You said what? Sorry?
15 plus 7.
Good. 15 plus 7. We need to find that full length of that side. So 15 plus 7, 22, right? Yeah. Yeah.
So, like, I've always wondered, why do you do that when it's, like, in the middle? Like,
Yeah, great question. Because see this line right here? It is falling on the huge triangle, right?
Yeah.
So like the other ratio only works because these lines are cutting the triangle proportionately on this side and this side. So the reason we have to use similar triangles is because this doesn't, it falls on the huge triangle.
oh, okay.
So that's why you have to use similar triangles. So we would do 15, could we use 7?
No.
No, it's not on the triangle, right? So we would do 15 over, what corresponds to that? 22 is equal to 12 over x. Does everybody see how I had to do that for that bottom part? Okay, let me say it again. We have this small triangle and the large triangle, and they're similar, right? So we have to set up to find the bottom one because the ratios don't work like this for similar triangles. 15 over 7 is equal to 16 over y. For similar triangles, right, we set up ratios of corresponding sides, right? So 15 corresponds to the full length, right? So 15 over 22 will be equal to, this is the bottom half of our small triangle, so 12 over, that corresponds to 12. So 12 over x. Is that better? Okay. Yeah.
So, there was a question on the board yesterday where, the smallest number was the, corresponding triangle to the big one, but, would you use that or the biggest one?
No matter what, it doesn't, that's a great question. You won't use big or small, it doesn't matter. You'll always use what's on the small triangle. Yeah. So you'll never, even if this was bigger, you have to use what's on the small triangle. Good question. Yeah, does everybody understand that? Okay, good. Very good question. So you're all okay with this? You're sure? You will see one like it. Okay. Okay, looking at this picture, it says, so if I told you, if the direction said on the test, and it will, these two angles are being this angle is being bisected. Angle A is being bisected by this line. And then they give you these things. AB is equal to 12, BC is equal to 2, AD is equal to 14, and then it asks you to find CD. Don't think so hard. Don't say, oh, I don't know how to do that. You do. Fill it in, and then it's going to look like everything we've done. So A to B is 12. So from A to B is 12. So I'm filling that in as 12. From B to C is 2. So from B to C is 2. And then from A to D is 14. A to D is 14. Now it says find CD. So find CD, right? Now this is an angle bisector. So we set up our ratios as such. 2 over question mark is equal to 12 over 14. Make sure on the test not to go like this. 2 over question mark is equal to 14 over 12. Not correct. Not correct. You've got to stay consistent. So if you start on the left, 2 over question mark, you got to go back to the left. 12 over 14. Are we okay with that? Then we cross multiply and solve. So multiply both sides by 14. Multiply both sides by also question mark, right? Divides out over here. 28 is equal to 12 question mark. Then we would divide both sides by 12. So we would get question mark is equal to 2.4. Okay, questions on that one? No questions on that one. Okay, we won't go through and solve this one, but if you saw something like this, it's an angle bisector, right? Just like the other one. So we would set up our ratios such as x plus 2 over what? 2x minus 5 is equal to, good, 7 over 8. Okay, now just remember these little things. It'd be sad to get this far and then not know how to do it. You cross multiply both sides by 8, but it divides out over here. We would cross multiply both sides by 2x minus 5, but it divides out over here. Now, can I just multiply? Like some people are just adding things. Are we adding? No. No, we're multiplying. These have to be in parentheses, right? Then we would have to double distribute, right? Over here, this has to be in parentheses. Has to be. Then we would distribute that through multiplication style, right? Do I need to keep going? Does anyone want me to keep practicing that? Keep going on this problem? Okay. So 8 times x is 8x, right? 8 times 2 is positive 16, so we put plus 16, which is equal to 7 times 2x is 14x, and then 7 times negative 5. Negative 35. So you put minus 35. Now from here, do not do what you did on the first test. There's a few people in this room I could point at you, but I won't, that just took 8x and 14x and floated them together. If you do that on this test, it would be absolutely insane because I'm hoping that by now we're good. So we don't just float them together. We have to get them together using the correct operation. So how do I bring 8x over? Subtract 8x from both sides. So those out to be 0. We have 16 is equal to 14 minus 8. 6x minus 35. Do you just float negative 35 and 16 together? Add 35 to both sides. So now you'll take your calculator. Since this is positive 16, you'll do 35 plus 16. 51? Yep. 51 is equal to what? 6x, because those add up to be 0. You better check and make sure your inverses match up. And then divide both sides by 6. So x is equal to 8.5. Now what if I said, now, because on the test they will say this, Now go back and find this side. Now that you found x, go back and find this side. How would you find it? Yep, just plug it in. 8.5 was x, so 8.5 plus 2 is 10.5, right? We'll have 2 answers on this one on the test. Okay, good. You could. On the test, it might say find one side or the other, find both. Yeah. Any questions? Okay. All right, so story problems. Just make sure you will see a couple story problems. But guys, we're dealing with similar triangles. All you have to do is draw your picture if you need to. Draw a picture, set it up right, and then all you're doing is setting up ratios of corresponding sides. On the review, there were story problems to help you practice. I hope you practiced them. But on this test, there will be ones that are just like worded. So do you want to practice one like that? That was all I have planned, but I can give you one. Yeah. Okay. So let's say I said, okay, let's say I said to you in the story problem, no picture, you have to draw the picture. If I said, Johnny and his dad stand by each other. Johnny and his dad stand by each other. So Johnny and his dad stand by each other. His dad is 10 feet tall. His dad is 10 feet tall. Now when a shadow is cast, when they're standing in the sun, a shadow is cast from the dad that's 3 feet long. And the shadow cast from Johnny is 2 feet long. So how tall is Johnny? Wouldn't you just draw a picture like this? How tall is Johnny? Do you see how I put the shadows down here? Yeah, and then they're just triangles. You would do x over 10 is equal to 2 over 3 and cross multiply. They're not going to be hard. It's just you have to be able to see. Does that make sense? And draw your own picture. They're going to be the same stuff. No harder math. In fact, easier math because they're going to be straightforward math, but you have to be able to draw a picture on some of them. Does that make sense? Okay. Okay, that's all I have planned. So we still have 20 minutes. So if you want me to go over anything with you on your review or anything, but really, do you guys feel more confident? Yeah. Okay.